Alright, in this last video, we're going to use something called functional groups. We will still name our chains, we will still name branches, but now we have branches that have a special suffix. If you look at the chart on page 731 of your textbook, it has a list of all these functional groups. The only problem with the chart in your textbook, it doesn't tell you how to change the suffix. So I've added them on this sheet. For alcohols, the suffix is OL, and alcohol will have an OH group attached to the chain. We've already talked about alkyl halides. Ethers, it'll have a chain of carbon and an oxygen in the middle, and then another chain of carbon. These will end in the name ether, so we'll name our two chains and then we'll stick the word ether on the end. Aldehydes, they have a chain of carbon, and at the very end of the chain it'll have a double bonded oxygen, and aldehydes end in Al. The next one are ketones. We have a chain of carbon, a double bonded oxygen, and then a second chain of carbon. So the difference between a ketone and an aldehyde happens at the end of a chain. A ketone happens in the middle of the chain. So we have a chain, carbon, chain, double bond O. Aldehydes, the double bonded O is at the very end. Ketones end in ONE. Next are amines, or amines, and they have nitrogen, and it has 3 chains attached to it. So we would name each chain, and then it's going to end in the word amine. Next are carboxylic acids. These also happen at the end of a chain of carbon. So we have a chain of carbon, a double bonded oxygen, and an OH. We've already seen an example of this in acetic acid. But most of our carboxylic acids end in oic and the word acid. And then the last one are esters. Esters also happen in the middle of a chain. We have a chain of carbon, an oxygen, a double bonded oxygen, and a second chain of carbon. And most of these end in O8, O-A-T-E. Alright, so let's look at this. I'm going to try to do one of each. The first one, 2-methylpentanol. So on the second carbon, we have a methyl group. We have a chain of 5. It has single bonds, and here it tells me OL. If it ends in OL, it's an alcohol. It has an OH attached somewhere. Well, here it's a 1. So on the very first carbon, I have an OH. That's my alcohol. On my second carbon, I have a methyl, and then I should have a chain of 5 with single bonds. So that is pentanol. On these functional groups, I'm not worried about molecular formulas, so that's why I marked all of this out. Alright, on the second row, this ends in oic acid, so that tells me, back on my functional groups, it's a carboxylic acid. So I'm going to have a chain of carbon, and then I'm going to have this structure on the very end of it. 3,3-diethyl hexanoic acid. So when we draw them out, it's easier to start with the chain. Hex tells me 6 carbon. 1, 2, 3, 4, 5, 6. 3,3-diethyl. So on the third carbon, I'm going to have an ethyl group. That's 2 carbons. Oic acid, so going back to my functional groups, carboxylic acids are on the end of the chain. It's a double bonded oxygen and a single bond OH on my last carbon. So I'm going to put a double bonded oxygen and a single bond OH. Alright, so that takes care of my 3,3-diethyl, my oic acid. Now I just need to add my hydrogens very carefully. this last carbon, we have a bond here, 2 here, and 1 here, so that makes 4. So we don't have to put any hydrogen on it. So now my condensed version, CH3, CH2, C, CH2, CH3, CH2, CH3, CH2, CH2, C, double bond O, single bond OH. So that is my carboxylic acid. Alright, third row. 2,5,5-trimethyl 3-hexone. Let's start with the chain. Hex tells me 6. And actually I messed up. It should be hex unknown. So it tells me that there are single bonds. So I need 6 carbon in my chain. It ends in ONE. So if I go back to my functional groups, ONE, that's a ketone. It happens in the middle of the chain. It's a double bonded oxygen. So if it's in the middle of the chain, I need to know where. So I'll go back to this. This 3 tells me my ketone. So on the third carbon, I'm going to put a double bonded oxygen. I also have a 2,5,5-trimethyl. So on the second carbon, I have a methyl, which is 1. And then the 5th carbon, I have a methyl on top and a methyl on bottom. So that takes care of my 3 branches and my functional group. So now I need to add my hydrogens. Here I already have 1, 2, 3, 4, so I'm not going to put any hydrogens on my third carbon. This carbon also has 4 bonds, so it doesn't need any hydrogens either. Alright, so that is my structural formula. Let's do condensed. CH3, CH, CH3 is a branch, C, double bond O, CH2, C, CH3 is a branch, CH3 is a branch, and then the last CH3. So that is 2,5,5-trimethyl 3-hexanone. Alright, fourth row. Pentanal. Pent tells me 5. AN tells me single bonds. AL, if I look at my functional group, tells me that it's an aldehyde. Aldehydes always happen at the very end of the chain, and it can be on the very first carbon or the very last carbon. It doesn't matter. So it's a double bonded oxygen and a single bonded hydrogen. So we're going to draw our chain of 5. On my last carbon or my first carbon, so either one of these could be considered carbon 1, we're going to put a double bonded oxygen and a single bonded hydrogen. That's it. So now we just fill in our bonds with hydrogen. This carbon has 1, 2, 3, 4 bonds, so it doesn't need any more. So our condensed version, CH3, CH2, 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 CH, double bond O. Alright. Ether, diethyl ether. Diethyl, that tells me 2. Ethyl tells me 2, and that means it's a branch. And then the word ether. So an ether has a chain of carbon, an oxygen in the middle, and a second chain. So what do you think my chains are going to be? They're going to be ethyls. So an ethyl has 2 carbon in it. We have to have an oxygen in the middle and another ethyl. So let me show you that again. Ether, we have a chain of carbon, oxygen in the middle, a second chain of carbon. Well, I have diethyl. So that means I'm going to use one ethyl as my first chain and the second ethyl as my second chain. So now I just fill it in with hydrogen. There aren't any other branches. We don't put any hydrogen on our oxygens, only our carbon. So now a condensed version. CH3, CH2O, CH2, CH3. Alright, the next one. Ethyl methanoate. Ethyl tells me a branch of 2 carbon. Meth tells me a chain of 1. AN tells me single bonds. O8 tells me that it's an ester. So we have an ethyl as one chain. We'll have a methyl as another chain. And then we have a carbon with a double bonded oxygen and a single bonded oxygen in the middle. So we'll start with our ethyl. That's 2 carbon. Then we have to have a carbon with a double bonded oxygen and a single bonded oxygen in the middle. So this right here is our ester. And then this says meth, which is just 1 carbon. So this is my ethyl, this is my ester, this is my meth. So now fill in hydrogens. This carbon has 1, 2, 3, 4 bonds. This one only has 1. Right, so now a condensed version. CH3, CH2, carbon with a double bond oxygen, single bond oxygen, and then a CH3. Right, and then the last type of functional group is an amine, trimethylamine. So I have 3 methyl groups. Methyl groups have 1 carbon. That's good because an amine is a nitrogen in the middle and it has 3 chains of carbon attached to it, or 3 branches of carbon. Well, I have 3 methyl groups. So my amine is a nitrogen in the middle. I'm going to put a methyl on each side. And then I'm going to fill it in with hydrogen. We do not fill in hydrogen for the nitrogen. We only fill in hydrogens for our carbons. If we wanted to get technical, there's some unbonded electrons there. Alright, so now a condensed version. So we're going to do CH3-N-CH3, CH3. It doesn't matter what order you put these in. Your unpaired electrons could be on the side, on the bottom, it doesn't matter. Alright, so that should be an example of each one of our functional groups. So you should be able to use these 7 rows to help you do this sheet and the back side.